The work that flight engineer Mike Hopkins has been doing today on the BP-REG experiment is an example of some of the human life sciences research that's underway on orbit. All of it is designed to find out as much as possible about how living in microgravity affects the human body. Now, that sort of work has been going on in spaceflight for decades now. This morning, we have a report to bring some perspective to that. Here's Lori Meggs at the space station's Payload Operations Integration Center at the Marshall Space Flight Center in Huntsville, Alabama.
Dating back to Apollo, it's been documented that astronauts' immune systems become suppressed in microgravity. A study is looking at why that happens. It's called T-cell activation in aging, and the study's principal investigator, it's a personal cause for her, Millie Hughes Fulford, who flew aboard STS-40, Spacelab's first mission dedicated to biomedical research.
We're looking at the immunosuppression in astronauts. We're using very complicated bioinformatics in order to look at all 30,000 genes involved. And from there, we are finding the way to modulate the immune system, not only for people in spaceflight, but also for people on the ground. For instance, older people, as they age, they have an immunosuppression. Something like 70% of the people in ICU that die have had pneumonia. We're also looking at ways to modulate the immune system for autoimmune disease. That would be when it's turned on too high. So the hope for our research is that we're going to be able to pinpoint the target areas that might make a good pharmaceutical target. My experiment, the first one flew on station some time ago. We published the paper 2012 about the experiment, and this is the next experiment following.
So what did you find in the first study?
In the first study, we found some of the very early signaling events that change in the immune system in microgravity. With this study, we're carrying it one step further. We're able to look at microRNA, where we will be able to have brand new pharmaceutical targets.
Why does this interest you personally?
I'm interested in the immune system because it's key to health, and it's something that's very dramatic in the astronauts, and so it's something easy to study because in microgravity we have removed a variable, gravity. And so like any mathematical problem that you take a variable out, many times you come out with a new solution. So I'm using microgravity as a tool to look at how the immune system's working and how to modulate it.
And that's why space station is ideal.
That's why space station's needed.
Tell me about your personal experience as a mission specialist and how that is carried over into the research that you're interested in.
In 1991, I was a crew member on STS-40. We had 26 experiments, and of those experiments, one of them was, the PI was Augusto Cogli, where he was looking at the immune system. I became very interested in how the immune system was working. Got to know Augusto. He called me later. He knew I was working with RNA, and he wanted to know if I'd collaborate with him, and that's how we started working together on the immune system.
And that'll do it for us here at the Payload Operations Integration Center in Huntsville. Now back to you at Mission Control in Houston.